Good morning, ma'am. My name is Sri Harshita from CSM department. Now I am presenting PPT presentation for CIE2. My topic is explanation based learning. First, we discuss about what is explanation based learning. In other words, introduction to explanation based learning. Explanation based learning is a technique in artificial intelligence that focuses on learning from explanations. It allows system to generalize from specific examples by understanding the underlying principles. EBL is means explanation based learning is particularly used in domains where data is scarce or expensive to obtain. Now we will discuss about in historical content of explanation based learning. Explanation based learning has its roots in early AI research during the years 1980s and 1990s. Researchers sought methods to enable machines to learn efficiently from a few instances. The concept of using explanations to enhance learning has influenced many AI methodologies. Next, we will discuss about key components of explanation based learning. The primary concept components of explanation based learning include examples, background, knowledge, and explanations. Explanations provide the rationale behind decision, enhancing the interpretability of models. Background knowledge enhances the learning process by providing context and structure. Now we will discuss about mechanism of explanation based learning. Explanation based learning operates by analyzing specific instance and extracting general rules from them. This process often involves identifying relevant features and relationships in the data. That learned rules can then be applied to new unseen situations, improving performances. Now we will compare about explanation based learning versus traditional learning. Unlike traditional machine learning, which often relies on large data sets, explanation based learning focuses on few examples. Traditional methods may prioritize predictive accuracy, while explanation based learning emphasizes understanding and reasoning. Explanation based learning can complement traditional approaches by providing a deeper understanding of learned patterns. Challenges in explanation based learning. One major challenge is the need for high quality explanations, which can be difficult to obtain. Explanation based learning systems may struggle with noisy data or contradictory information during the learning process. The balance between generalization and specificity is critical to effectively learning outcomes. Now we will discuss about one of the example in explanation based learning. An example of explanation based learning is using a perfect domain theory is a program that learns to play chess through example. A specific chess position that contains an important feature such as focused lots of vacuum in two moves, includes many irrelevant futures, such as the specific charactering of cows on the board. Explanation-based learning can take a single training example and determine what are the irrelevant futures in order to perform a generalization. A domain theory is perfect or complete if it contains, in principle, all information needed to decide any question about the domain. For example, the domain theory for chess is simply the rules of chess. Knowing the rules, in principle, it is possible to deduce the best move in any situation. However, actually making such a decision is impossible in practicing due to combinatoric exploration. Explanation-based learning uses training examples to make searching for deductive consequences of a domain theory efficient in practice. In essence, an explanation-based system works by finding a way to deduce each training example from the system. Exciting database of domain theory. Having a short proof of the training example extends the domain theory database, enabling the explanation-based system to find and classify future examples that are similar to the training example very quickly. The main drawback of the method, the cost of applying the learned macros, has this become numerous was analyzed by Menton. Basic formulation of explanation-based learning. Explanation-based learning software takes four inputs. A hypothesis space means the set of all possible conclusions. A domain theory, axioms about a domain of interest. And training example means specific facts that rule out some possible hypotheses. And last one is operationality criteria, means criteria for determining which features in the domain are effectively recognizable. Example, which features are directly detectable using sensors. Now we discuss about some of the advantages of explanation-based learning. Explanation-based learning improves learning efficiently by reducing the amount of data needed for accurate predictions. It enhances model interpretability, allowing users to understand reasoning behind conclusions. By level-aging explanations, explanation-based learning can lead to more robust and adaptable AI systems. Now we will discuss about future directions in explanation-based learning. Future researchers may explore integrity explanation-based learning with deep learning to enhance interpretability. There is potential for developing more automated methods for generating explanations. Advantages in human AI collaboration would leverage the explanation-based learning to create more intuitive systems. Now we will discuss about some of the applications of explanation-based learning. Explanation-based learning has many applied in various fields, including natural language processing and robotics. In medical diagnosis, explanation-based learning helps the system learn from fewer cases while maintaining accuracy. Educational technology uses explanation-based learning to customize learning experience based on student interactions. An especially good application domain for an explanation-based learning is natural language processing. Here, a rich domain theory, that is a natural language grammar, although either perfect nor complete, is turned to a particular application or particular language uses. Using the tree bank training examples, the first successful industrial application was to a commercial LI interface to relational databases. The method has been successfully applied to several large-scale natural language pursuing systems where the utility problem has solved by the original grammar and using specialized LR pursuing techniques, resulting in huge speed up at a cost in coverage, but with a gain in disambiguation. Explanation-based techniques have also been applied to surface generalization and the converse of pursuing. Next, we discuss about the conclusion of explanation-based learning. Explanation-based learning represents a significant advancement in the field of artificial intelligence. It focuses on understanding and interpreting learning processes, make it a valuable tool. As AI continues to evolve, explanation-based learning will likely play an important role in shaping intelligent systems. Thank you.